Hi, I'm sorry. I was thinking I was going to get a slight introduction, but I think we decided we weren't going to do that. So my apologies. Good morning. My name is Sonia, and welcome to this first webinar in the Building Smart program from DTE and Consumers Energy. This is an introduction to the webinar series, and we'll give a sneak peek to a little bit about some of the things that we'll be covering over the next several weeks. It's raining here where I am, and so my bandwidth is a little bit shaky. I'm going to turn off my camera during the webinar, and then I'll turn it back on for questions afterwards, just to kind of conserve bandwidth here. All right. So next slide. Okay. So today we're going to be talking about, we'll talk a little bit about the utilities that are offering this program, and then we'll talk a little bit about what we hope you get out of this program over the next several weeks. And again, we'll have a brief overview of the program. We'll talk a little bit about the program schedule, and I'll give you just a little bit of information on high performance homes, some of the definitions, benefits, and opportunities that they present. Next slide. So Consumers Energy provides services to over 6 million customers across Michigan. It's one of the two largest investor-owned utilities in the state, and they serve, again, over 6 million customers, a large portion of the state's customers. All of the 68 Lower Peninsula counties are served by Consumers Energy. It was founded actually in 1886, and a fun fact about Consumers is that in 2018 they became a title sponsor for Monster Energy NASCAR Cup Series, a race that is held at the Michigan International Speedway. Next slide. The second of Michigan's large utilities is DTE Energy. And this utility began back in 1849 and was originally known as the Detroit Gas Company. They've had a number of changes in name over the years. And so now we call them DTE Energy, or they call themselves DTE Energy. They serve natural gas to about 1.2 million Michigan families, and provide services in over 500 communities across the state. A fun fact about DTE is that back in 1996, it was actually known as Detroit Edison. At that time, they were Detroit Edison established a holding company, and the stock ticker symbol was DTE. So they decided to name the holding company DTE. And they included energy because that was the direction the company was going. They were being a more holistic energy company, not just electricity. Next slide. Thank you. So these two utilities, right? We know that pretty much every utility across the state is holding energy efficiency programs, but these two utilities are anchoring that effort. And as a result of their efforts, our energy efficiency programs ranked #1 in the nation last year. We were tied with California. And this is just really an indication of how utility energy waste reduction efforts in Michigan are really helping to lower customer bills by reducing waste and unnecessary energy use. This award was provided by ACEE, and they also found that Michigan's energy waste reduction programs were getting the results, again, similar to California, because we tied first place with them, but we were doing it more cost effectively, or are doing it more cost effectively. So we're spending less money than other states, and we're getting better savings. So this is a real feather in our cap and a testament to the commitment of the two utilities um, to reducing energy usage across the state. Next slide. Thank you. So what we hope that you will get out of this series of webinars um, is some skills that you can take as you are out in the marketplace, whether you're an architect or an engineer or a contractor, um, in dealing with clients and homeowners, being able to better explain some things to them. So, looking at the concept of a high performance house, what is that? What does it mean? And what does it mean in terms of dollars and cents? Being able to compare and contrast various types of high performance houses, and being able to implement some of the best practices in design and construction of passive houses, of high performance houses. Also, we hope that you're able to incorporate some new technologies into your construction projects that will provide for a better occupant experience, because that's, at the end of the day, what everybody is looking for. That's the goal, that's the outcome. And lastly, we hope that you'll be able to use some above code programs, and we'll be talking a lot over the course of these several weeks about a number of above code programs that can assist in reducing energy waste and making homes more efficient and more comfortable with improved indoor air quality. Next slide. So we have two instructors that'll be providing training over the next several weeks. The first is Chris McTaggart. Chris has been in the energy efficiency industry for more than 15 years. He is a accomplished trainer for the International Energy Conservation Code. He's taught a number of courses and a number of students, both in person and online. And he is a quality assurance manager for the whole HERS program, or the Home Energy Rating System program. Next slide. The second speaker is myself, and I'll be your speaker for today. My name is Sonia, and I have been in the industry more than 20 years. I've had a number of experiences. The bulk of my experience has been in energy efficiency and building performance management. But I started my career as a equipment development engineer with a manufacturer. I've been a member of ASHRAE for a number of years, and I like energy code training and all this kind of technical stuff. So I hope that that you enjoy the session today and that you find it educational and beneficial. Before we move into the sessions or the details of today, I want to find out a little bit about you. So, next slide. We've got a poll here that my wonderful technical helper, John, is going to put up on the screen for you. And there should be a toolbar across the bottom that if you need instructions on how to use the poll, but you should just be able to take your mouse and click on one of the answers and then hit save. If you scroll down, you'll see a couple more responses to question number 2. And I'll give everybody just a minute or so to go ahead and respond to that poll. Okay, John, do we have an answer? We've got some responses. Oh, wow. Okay, so to the to the question of who's in the audience, we've got a third of the people are energy raters, and a third are nonprofit. Okay, and then we've got some utility folks. So a third. Okay, a third, a third, a third. That's an interesting. That those numbers came out perfectly like that. And let's see to the second question. And actually, yeah, well, the energy raters, I might have a couple of questions for you. But let's see the how long have you been in the industry? And so we've got okay, about a third there, and a third there as well. So we've got some folks who have been in the industry from 0 to 5 years, and we've got some folks that have been in the industry up to 15 years. Um, all right. So we don't have anybody that's been in there longer than that. All right. Okay. Well, good. Well, hopefully this information will prove beneficial to you. The energy raters, I don't know which category you fell into, whether you were the folks who'd been in the industry a short while or whether you were the more seasoned people. Um, but hopefully the seminar will prove valuable to you as well. All right. So next slide. All right. So now let's get into an overview of the program. So this program will be provided to you in modules, and each module will last about 3 to 6 weeks, covering various topics. They're all live webinar sessions. They are being recorded and they will be archived, which you can access at your leisure. After each webinar, there will be a follow-up survey. You'll receive that a link to that email. And if you could uh, respond to the survey, that would really help us to improve the program. You might see questions like, what else are you interested or do you in learning about, or do you have any specific questions about some of the topics that are in this webinar series? Whatever information you can provide, we would really appreciate it. Again, we'll take that information and we'll use that to just improve the program so that we deliver something that's of value to you. Over to the right, you can see there's a calendar that's marked up a little bit with the dates for the programs highlighted. So you can use this as you're planning out your summer months and your schedule to make sure that you don't miss one of the webinars. There's a registration link here that's provided as well. You've used the link because you've signed up and you're here at this session, but you may have only signed up for one session or just for a few of them. You can either sign up for all of the sessions at once, or you can do them individually, on a weekly basis if you choose to do that. Next slide. Thank you. So in this first module, we're going to be talking about some real basics. We'll talk about general building science. There we'll begin to talk about airflows in buildings and equipment, what equipment goes into a building, what the energy consuming equipment is, how building systems work, how buildings are designed to maintain comfort conditions. We'll talk a little bit about energy efficiency design theory in the next session. So there we'll begin to talk about energy use within buildings and some of the things that we do, some of the new technologies that we've begun to employ that will help improve energy efficiency. Then we'll talk about minimum good design, which is really kind of our bare minimum, like legally the worst building you could build. This will be that building, the very minimum that you will do to just get your permits approved and I'll pass all of your inspections. And then we'll offer an introduction into the above code programs. This will be a very brief introduction because again, we'll be doing a deep dive into the above code programs later in the series. Next slide. In Module 2, we'll begin talking about the thermal envelope. The thermal envelope, many of you already know that the thermal envelope is an extremely important building system. They're all important, but the thermal envelope is really kind of the first defense against outdoor weather, right? So if you don't have a good envelope, regardless of how efficient your HVAC system is or any other system, you're going to be wasting energy if you don't have a good thermal envelope, if your building is not sealed. So we'll be spending some time talking about that. We'll talk about types of insulation, R values that are required in this area, R values that are suggested for this area or this state, how to properly install insulation, particularly for a continuous air barrier. We'll talk about sealing, finding leaks, and correcting them in residential buildings. And then we'll begin to talk about fenestration, which is, the windows, skylights, and on the residential side, we consider doors fenestration as well. Not so much on the commercial side, but on the residential side, we do consider the doors to be fenestration. So we'll be talking about those components and how they interact with the thermal envelope, and how they combine with the insulation to make sure that the home is able to maintain comfort conditions. Next slide. During Module 3, we'll begin to talk about, we'll begin to break down some of the systems. We'll be looking at the mechanical systems in the house. So here we'll look at air distribution systems, so fans and ductwork, furnaces, things of that nature, heating equipment. And we'll also be talking about hydronic systems and water distribution. So here in Michigan, we do still have, we have a number of houses that have boilers, steam boilers and hot water boilers. And we'll talk a little bit about those systems. We'll spend quite a bit of time talking about mechanical exhaust. This is really important for good indoor air quality, particularly as houses now are tighter, right? They're more airtight. They're sealed better, right? If we've got a tighter envelope, which would be, the previous module, right? It's important then to to make sure that we've got good indoor air quality. And one of the ways that we do that is with mechanical exhaust. And so we'll talk about that as well in the context of whole house ventilation as well as local ventilation. We'll talk in detail about the HVAC control systems. Obviously, programmable thermostats will be a big part of this program, but there are other HVAC controls as well that we'll be addressing. And we'll talk about the importance of making sure that the equipment is properly sized for the facility. Oftentimes people think, oh, bigger is better. If you need, 40, 60, 80, 100,000 BTUs per hour, I'll give you 15% more. I'll give you 20% more. Well, in terms of energy use and energy consumption for facilities, bigger is not necessarily better. There are several challenges when you have equipment that's oversized, as well as challenges when equipment is undersized. So we'll talk a little bit about how to avoid those and how to properly size. And you may want a little bit of cushion in the equipment capacity. We'll talk about what amount of cushion is appropriate and economical. Then we'll talk a little bit about some of the non-comfort applications, things like snow melt, for if you live in Holland or other places across the state that might use that. And we'll talk a little bit about the electrical systems as well. We'll spend some time talking about solar. That is becoming increasingly popular across the state. And we'll talk about opportunities there, solar photovoltaic, as well as solar thermal. Next slide. In Module 4, this is where we'll do a deep dive into the above code principles, or begin that deep dive. Here, we'll start talking about, we'll lay a foundation with the HERS rating system. We'll review what that system is, how homes are rated through that, and we'll begin to talk about how some of these programs interact with the utilities, right? So, for example, both DTE and Consumers have a new homes program, and one of the criteria in there in those programs is to have a HERS rating. We'll discuss how that program and those rating systems interact and how you can use them to provide better facilities for your customers. We'll talk about Energy Star programs and what they offer in terms of high performance homes. So Energy Star has a number of programs for both single family and multifamily. We'll start off talking about their single family opportunities, and then we'll talk about the Energy Star next gen homes, right? What's coming up next? What's coming down the pipe? What are we planning for that's going to be really energy efficient and just kind of knock your socks off? Next slide. The part 2 of the above code principles part of the webinar series will look at some of the zero energy opportunities that are coming online. So there's a DOE Zero Energy Ready Home program. It's a pretty comprehensive program, so we'll break that into 2 webinar sessions. And then we'll talk about the EPA Indoor Air Plus program, Passive House program, and some other opportunities with rebates through DTE and Consumers. And then we'll have a series or a webinar actually dedicated to questions and answers. So over the course of the webinars, certainly you can feel free to ask questions throughout these sessions, but we will also have a kind of a wrap-up session at the end where it's just kind of a free-for-all. We'll get all your questions on the table and get them answered and see how we can best be of service to you as you go out and promote high-performance homes in your neck of the woods. So that's kind of an overview of the program and what we'll be talking about over the next several weeks. Now I'm going to move into today's topic. Next slide, please. So this is, again, just a very, very high-level overview. This is not meant to be a deep dive at all. We'll do that starting next week. But this is just to kind of give you a little taste. Next slide. We have another poll come up. All right, so before we do that, before we go into the next program, let's do our second poll. John, you ready to pull that up?
Yeah, I sure am. Would you remind me which poll that is? Is that the familiarity with high performance homes?
It is. Yep. So we've got 2 questions for that poll. The first is how long folks have actually. So we asked them earlier about what their experience was already. So I guess we don't need to do that one again. But yeah, how would they characterize their familiarity with high performance homes? All right, we've got some answers. All right. So we don't have anyone here who has not heard of high performance homes. That's awesome. And we're split 50-50. This is very funny. I'm curious to know how this math is working out very interestingly. But we've got a perfect split here. So this will be good. So some of you have actually worked on some high performance home projects. So when we have opportunities for feedback and for discussion, I'm hoping that you will chime in and be able to share some of your experiences and lessons learned. I think that will just make for a more rich conversation as we move through the series. Thank you. All right. So the high performance home. So if we look at just, in a word, what does this mean? These are houses that are designed and constructed to be capable of being operated in ways that increase environmental and economic value over time, right? In a word, these homes are more sustainable, right? They're going to retain their economic value, um, and they're going to not have uh, large negative impacts on the environment, uh, depending on which program a high performance house falls into. It could actually be, for example, a net positive house that is actually benefiting the environment. Uh, High performance homes also provide a good indoor environment that supports the health of the occupants. I mentioned earlier that as we're making homes tighter, there are concerns with indoor air quality. A lot of homes in Michigan are older homes, and many don't have ways of bringing in outdoor air. Right, when years ago, as we were building homes, uh, it was the design that homes brought in outdoor air whenever doors were opened or where the windows were opened. And many people would keep a window open or at least cracked all year long to bring in fresh air. That's how they would get the fresh air into the house. That's why often you see in older facilities there are radiators. If the house has a boiler, there are radiators right up under the window, right? And that's partly because um, we kept the windows open in order to get fresh air into the home. And so you wanted to make sure that that did not make people uncomfortable and cold during the winter months. So high performance homes help alleviate that problem. They do that by bringing in fresh air um, from outdoors, and we'll talk about how they do that over the course of this series. High performance homes also enhance occupant satisfaction and productivity. Often, when we think about satisfaction and productivity, we think about those in terms of commercial facilities, not always in residential facilities. But if you think about it, if you were to talk about, productivity improvements, for example, in a school, well, children do their homework at home, right? And so they're thinking in spaces outside of the school classroom, right? They're doing that in their houses. And so if they have poor indoor air quality at home, right, that will impact their ability to perform there, their productivity there. There also have been studies that look at um, the performance of adults in matters of thinking or in activities in the home. And we have found again that if you have poor indoor air quality, it doesn't matter whether it's in an office building or if it's in your house, it's still going to negatively impact your productivity, right? So high performance homes use environmentally friendly materials, and they use more efficient systems that alleviate these problems. So, for example, you won't see, high VOC carpeting in homes, right, or high VOC paint, right? You'll see high performance homes are using products that um, off gas significantly less and significantly faster than some older traditional components. Next slide. So one of the big benefits of the high performance home is the reduced energy use. And high performance homes have a reduced demand for energy, right, specifically for heating and cooling, for a number of reasons. One, they are predicated on higher insulation values, right? Higher than typical insulation values. And so that again forms that thermal barrier, which again is that first defense against outdoor inclement weather. High performance homes also have high performance windows and doors. So in an older home in Michigan, you might see single pane windows. If the homeowner has upgraded, they might have double pane windows. High performance windows would either be double pane with some inert gas in between the panes, low E coating, or they might actually be triple pane windows with all of those same things, right? To further reduce um, heat loss through the window and solar heat gain through the window as well, right? Both to make the house more comfortable in both winter and in summer. High performance homes use high efficiency heating and ventilating equipment, right? Heating and cooling equipment. So there are national standards for the efficiency levels of equipment, and that national standard is just the floor, right? Manufacturers can make equipment that is significantly more efficient than that baseline value. And many manufacturers do. Often, homeowners may be frightened by the additional cost or the what they think the additional cost might be for that more efficient equipment, and so they may be leery of making those purchases. But when we begin to talk about the total cost of ownership, when we begin to look at the life cycle cost of the space heating and cooling equipment, not just the first cost, but look at the energy cost over its lifetime, and then of course what it's going to cost to maintain as well. Very often there is a solid argument for selecting more efficient equipment. And that is one of the staples in a high performance home. The same holds true for water heaters, particularly today where we have water heater technology is just expanding, right? So in the past, you had water heaters that may have been gas or electric, but they just had a valve, right? And they either turned off or on in response to whether or not there was enough hot water in the tank. Today we have tankless water heaters, right? They're on demand, so they only provide hot water when there's a call for hot water. So they eliminate waste that's used to store hot water. There's no reason to do that. Today we have water heaters that have programmable internal thermostats, so they can, for example, be turned down while the homeowners are away at work and school. When nobody's at home, there's no reason to be heating water and maintaining water to a high temperature level. They can also be turned down when, for example, someone goes on, when the family goes away on vacation. If you're away from the home for a couple of weeks, there's definitely no reason to maintain higher water temperatures at that point, right? And then, of course, high performance homes have lighting, right? Very often we'll see LED lighting in high performance homes, and we know that LED lighting uses about 25% of what, or sometimes even less, of what an incandescent bulb would do. Now, with LED lighting, we do need to kind of educate the homeowners a little bit, although they've been on the market for a while, so most people kind of understand now that with LED lighting, we aren't looking for example, at watts to determine how much light we're going to put into a space. We're really looking at lumens, right? We're not looking at the amount of energy. We're looking at the amount of light input that we're putting into the space. And so, so with the lighting, as well as all of these high performance building systems and components, there's an educational component that we have to provide to our homeowners to make sure that they fully understand the benefits of these features and why these features make the home a high performance home. Next slide, please. So we talked a little bit about indoor air quality. Excuse me. We were talking about indoor air quality, and this is a very impactful feature of high performance homes. Your typical home, as I said, here in Michigan with older construction, most homes do not have a means of bringing in outside air other than through open doors and open windows, and perhaps small cracks in the infrastructure in the facade, right? And so you have a number of contaminants that may get into the home and that may linger in the home for a period of time. So things like paint fumes from when we paint our homes or repaint our homes, viruses and bacteria, right? If somebody's in a home and they sneeze and the house does not have good air exchange, right? That sneeze could, linger in the air for a while, particularly if the house is dry, as you might have with a Michigan home that has, for example, a boiler as opposed to, a forced air system. Right? We have cleaners in our homes, right? We are constantly making sure that things are clean and sanitized. And some of these cleaners have some, chemicals in them that, are not necessarily to our benefit, right? They don't help our health, right? Radon is something that we see not often in Michigan, but it is certainly something that we encounter in Michigan, right? Seeping in through the ground soil, through our basements, right? And so this is a soil chemical that we do not want to have in the home. We can certainly have ventilation systems that address the radon issue, but most older homes don't, right? We don't have sensors either to indicate whether or not there's a problem, and so we aren't aware if there is. If we've got some gas consuming appliances in the home, then we have the opportunity for some incomplete combustion at times, right? And so there may be some CO in the space, as well as CO2 from people breathing, right? This is technically CO2 is a contaminant. We want CO2 levels indoors to be, not too much higher than they are outside. That's an indication of good indoor air quality. And so, in commercial spaces, we would have, demand control ventilation to mitigate the amount of CO2 that's rising in the environment, because that is one of the contaminants that we do know impacts productivity and alertness, right? And so if we have that in a home, in a residential facility, it would do the same thing to our productivity level as it would in a commercial space. So we want to limit that. There's been a lot of talk in the industry of late about cooking fumes in the homes, right? A lot of homes have gas stoves. And again, as we make our homes more airtight, particularly when we're retrofitting existing homes, if we have these stoves that do not have range hoods over them, there's no way for those fumes to be captured and contained, right? And so they just kind of linger in the space. And Sometimes, we notice those fumes because there's a smell to them. If you're cooking fish or something like that, there may be that. But even if we don't notice, right, even if there is no smell, those fumes are still lingering in the home. And that, could be bad, particularly if you have a child with allergies or if you yourself have allergies, right? That could be an issue. And then, of course, bacteria, similar to the dust and mold and things like that are in the homes, and carpeting, right? Carpeting has VOCs that off gas, similar to paints, right? It's very similar to that that new car smell, right? Um, and depending on the quality of the carpeting, right? Those VOCs may be off gassing for quite a while. And so when we look at high performance homes and their mechanical ventilation systems that are bringing in outside air and exhausting used stale indoor air, right? These systems help to improve the performance of these facilities. Next slide. So just a brief history, and I'm looking at the time here, and I'm going to kind of speed things up a little bit. Just a brief history of the passive house. So we talked about that airtight envelope. Passive house was actually started. The concept was actually started here in the U.S. in the early '70s as a response to the oil embargo. I don't know if anybody here is old enough to remember when that happened. I was a very, very small child at that time, but I do remember hearing things in the news about it. And so oil prices tripled, and the U.S. was in an energy crisis. And in response to that, some engineers and architects over at the University of Illinois designed what they called a low-cal house. They primarily did that using a highly insulated envelope. We've talked previously about the importance of the envelope for the passive house. And from there, the concept made its way over to Germany, and the climate changed here in the U.S. And that design concept kind of fell a little bit out of favor. It wasn't as popular as it had been, right? Around the 1980s. And so some folks over in Germany took up the concept and ended up making some improvements on this super insulated envelope, and were able to significantly reduce the home's heating demand, right, by nearly 70%. And so they then founded what is called the Passive House Institute. And that performance standard that they achieved, that's pretty much become the standard for the passive house today. Then later on, several years later, around 2003, a Miss Katrin Klinenberg was studying architecture in Berlin, but she's from the U.S. And so she modified the principles from that they were using there in Germany and applied them to a home here in Urbana, Illinois, and designed the first U.S. house built to passive house standards, and that was in 2003. The house is named the Smith House. Since then, passive houses have come back into favor. There are a number of them. And in 2012, we had our first certified passive house here in Michigan. Next slide. So that Michigan house is called the Young House. It's over in Holly, Michigan. Depending on where you are in the state, you may pass it sometime. But this house has, as you can see, R63 for the walls, right? Significantly super insulated, right? They've got a truss roof with R100, right? So again, and you can see here, they have triple glazed windows. Excuse me, I'm a little tongue tied. Uh, but they've got triple glazed windows. And so you can see they've got a very low air leakage rate, right? 0.4 air changes per hour. Um, so they've got some mechanical equipment that does bring in some outdoor air, right? They've got a whole house ventilation system. But they did this house in 2012 at a construction cost of, a little over $200 a square foot. Next slide. Since that house, there have been a number of passive houses that have been constructed in Michigan all across the state. You can see here from Spring Lake all the way down to a recent project at the John Grace Arms in the Detroit area. So when people build passive houses, it seems like everybody just decides that their house has to have a name. So that must be the thing for passive houses. You can't have a passive house without having a name. Next slide. So there are a number of different types of passive houses, a number of different design standards which one might use. And we will be talking about these over the course of the series here. But some of them are from the Passive House Institute. So those are the FIAS Plus and the FIAS Core. The differences in some of those houses is initially the standards were based on performance only, and now we have I think last year they just reintroduced a high performance house that is based on a prescriptive approach. So it's kind of like a formulaic approach to constructing the home. But we'll be discussing those, and then those will be some of the things that Chris will be discussing. Next slide. So the benefits of passive houses or high performance houses, right? The slide says up to 60% reduction in utility costs, but some passive houses have had even greater than that, more than that. So there's a significant opportunity to benefit homeowners. Improved indoor air quality, which we've talked about. Maintenance costs, right? So because you have more robust equipment in the home, that home it tends to operate better and require less maintenance. And you have better sound acoustics. So because you've got these very insulated walls, right, you don't hear as much of the outdoor noise, right, in the homes. And they last a little bit longer. Not a little bit longer, they last significantly longer than traditional or code-built homes. Next slide. So when we look at code-built homes, you can see that over the years, the energy consumption of a code-built home has gone down, right? So from 1975 to 2021, right, they've gone down about 60%, right? But that is over, a 45-year period. If we look at, next slide, what high performance homes can do, right? They drop energy use significantly. So if we look at the Energy Star home, right, it uses between, 10 and 30% less energy than a code-built home. But if we go to the passive house, right, there we're using, between, 80 to 90% less energy than a code-built home. And of course, net zero would be using 100% less energy. Next slide. When we look at Michigan's housing stock, we can see, right, the age of our homes, right? And so we can see if we understand the characteristics of construction at various times in American history, we can understand that there's a lot of opportunity in Michigan to retrofit housing stock. If we want to improve the overall housing stock, certainly we're going to build new homes to better or to more rigorous standards and to be more energy efficient. But there's a significant opportunity in older homes and retrofitting older homes. Next slide. Now we can see here, this is a study that came out of the EPA. This is looking at energy use in Michigan homes and some of the opportunities that there are to reduce energy use and the value in terms of savings for the average consumer right, in terms of what the savings could be. And so you can see here, there's a lot of opportunity in filling cavities, right, with insulation. So we have a lot of homes here in Michigan that actually are not insulated, either the above grade or the basement walls. There's lots of opportunities to improve the lighting in homes, opportunities to provide heat pumps, ceiling and attic insulation, insulating ducts, right, making the home more airtight, right, sealing up that house envelope. Those are all the opportunities, many of the opportunities that there are to reduce energy use here in the state. Next slide. When we talk about the cost of a high performance home, often we think of, the traditional model of, ownership costs. So we look at, okay, what does it cost to acquire the house? What's the upfront purchasing cost? What does it cost to operate? What are the utility bills going to be over the course of the house? And then, of course, maintenance, if you've got repairs that are going to have to happen. And over the course of the house, the life of a house, equipment is definitely going to have to be repaired and maintained. And then what does it cost to demolish it or salvage it? And those are the concepts that we really think about. But when we think about a passive house, next slide, please, thank you. We really want to look at a more holistic view for how we look at the cost of ownership. So we still want to include those things like the planning and the upfront, the financing, the cost of acquisition. But we want to include some other things that we don't always think about. For example, the raw material sourcing. So where's the material for the house coming from? What's going on in the community, where that's coming from? What's the impact in that community? Who in that community is getting this raw material, and how are they doing that, right? What types of for example, PPE and other things are they being provided, right, to get this material? How far is this material coming? Because if it's not local material, then you've got transportation costs, right, that impact the total cost of the home. And then, of course, you still have the construction and the operational costs. But then we begin to look at within operation, not just what the energy and the water costs are, but what about the emissions from the fuel consuming or the energy consuming components of the house? What are the costs to occupant health? If you have a child whose asthma is exacerbated because of the VOCs off gassing from the carpet, what is the cost of that? Right. And then, of course, looking at maintenance and decommissioning as well. And when we decommission here with this broader view, we don't just look at demolishing something and putting it into a landfill, but really, looking at opportunities to deconstruct things, reprocess it, reuse it. Um, and then what are the community impacts for that? Next slide. So, some of the elements for a high performance home are, siting, how the house is oriented on the land, which direction things are facing, how is it oriented, which direction is facing south. Do you have, a lot of windows on the south side, or are they on the north side, right? That will significantly impact the performance of the house, right? So material choices. Again, we've talked about low VOC materials, low materials that don't off gas, um, of the higher performance thermal envelopes, so the better insulation. The use of renewables also, right, is significant with passive houses. Oftentimes, you'll see passive house heating systems that are ground source heat pumps, for example, or other you know more efficient systems. Next slide. Some of the characteristics of the high performance home. So we've talked about these. This is kind of a review here. The energy efficiency, better indoor air quality, longer building life. They've been third party certified. So they have, the homeowner has an assurance that the house is performing as it says it is, or as the certificates say that it is, right? So not that our builders are not being honest with their homeowners, because they are, but you always feel better if you've got a third party independent person that said, yeah, I tested it and they did a good job, right? This house is performing the way that they say it's performing. This is an A plus house, right? Or this is a B house. And these can be applied to multifamily or single family facilities. Next slide. And so when we talk about opportunity here in the state, I just want to spend a little bit of time on this slide here. So Michigan has a statewide housing plan. There's a goal to rehabilitate or provide, new 75,000 housing units. Right now, some of that is multifamily, but some of those are single family as well. Many of them are multifamily, right? And they're on their way toward meeting that goal, right? So this is a study produced by MISTA that's tracking this information, right? So they had a goal of 75,000 last time I checked, which was yesterday. They were at 68,576 building permits, right, to upgrade homes. So this is just to give you an idea of the opportunity that's out there. So MISTA had a goal of upgrading or providing 75,000 homes, but the need across the state is much more than that, right? And even the 75,000 wasn't their initial goal, right? They were going along and they were going to surpass that goal, so they increased it. So there's still opportunity, significant opportunity to improve homes across the state. Next slide. Both DTE and consumers have rebate programs that can assist with that. You're here at this webinar, so I'm assuming that you're familiar with the websites for both of these utilities and have used their utilities. I don't know if you are trade allies. Maybe that's one of the questions that we'll ask in the next section, whether or not you're a registered trade ally for the program. But both utilities have programs that offer rebates for various home improvements as well as new home construction. Next slide. So that was the DTE website, and this is the consumer website. They differ a little bit with the DTE program. You kind of just go into the website and you can see everything there. With the consumer's website, you go into specific building systems. So it's either the the appliance program or the HVAC program or whatever program you may be interested in. And the rebate information is there. You can download applications. You can contact utility personnel to get assistance with those programs, whatever you might need. Next slide. And with that, we are wrapping up. And I think that I talked a little too slowly. And so we don't have a lot of time for questions, but if there are any, I would like to give an opportunity for anyone to ask the question that they may. And while I'm giving you that moment, I'm going to go ahead and put the next slide up that talks about the next session. But again, if there are any questions, feel free to either unmute yourself or to raise your hand. Your toolbar is at the bottom of your screen. Our next session is going to be next Tuesday at this same time, so 11 a.m. to 12 p.m. And we'll be talking about building science and energy efficient design. And I promise that I will talk a little bit faster so that we have more time at the end for questions. But this is the information for the next session if you are interested. And I do hope to see you there.
Great, thanks, Sonia. Doesn't look like there's any Q&A coming in or questions coming in at this time. So I want to thank you. I want to thank the attendees. And like I said, I hope to see everyone in the future for some more trainings. But yeah, excited to get this kicked off.
All right, thank you. Thank you all so much. We appreciate it. And I look forward to seeing you next week. Have a good day.
All right. Thanks all. Bye.